Okay, working through my final exam for my algebra-based physics course, problem number 4 out of 5. This is the second semester with electricity and magnetism and stuff. So here I have two wires carrying electric currents of 1.5 amps, and they run in and out of the pages as shown. So this X notation means that that's a current going into the page, and this dot means it's coming out like that. And then that's 5 centimeters, 5 centimeters. What's the vector value of the magnetic field up here? Okay. And then what happens if I change direction? So here we need to remember that the magnetic field, the magnitude of the magnetic field due to a wire is, and this is not something you need to remember because I have it right here, B equals mu naught over 2 pi r, mu naught I over 2 pi r. So I is the current, r is the distance from the wire. But it's also a vector, right? And so I need to actually first get vector notation for which direction these are. If I think about this wire right here, it's going into the board. So it makes circular magnetic fields, and I can use my right-hand rule. So if I put my thumb in the direction of the wire, my fingers show the direction of the magnetic field. So when I get over here, let's call that's 2. B2 is going to be this way, in the y direction. Now what about this one? This one I put my thumb in the direction of the current, and it's going to be going this way. Now I do know one other little trick here. I have these two vectors. They're going to have the same magnitude. The currents are the same. The distances are the same. So I only need to find one B. So let's say B equals mu naught over 2 pi times the current 1.5 divided by the distance of 5 centimeters, so 0.05 meters. And mu naught, which I give, is 4 pi times 10 to the negative 7th. So let's just put that in here. So it's just going to be 4 pi times 10 to the negative 7th times 1.5 over 2 pi times 0.05. So the pi's cancel, the 2's cancel, and I get 2 times 10 to the negative 7th. Let's put that in my calculator. That's not my answer. This is my magnitude for one of them. Okay, so now I have 2, enter. I'm sorry, drop that. 2 times 10 to the negative 7th, enter. 1.5 times, and then 0.05 divided by. And I get 6 times 10 to the negative 1, 2, 3, 4, 5, 6 Tesla. Okay, so now B1 is going to be equal to the vector negative 6. B1 is in the negative x direction. Negative 6 times 10 to the negative 6, 0, 0 Tesla. B2 is in the positive y direction. So it's going to be 0, 6 times 10 to the negative 6th, 0 Tesla. So B total is going to be B1 plus B2. But they're vectors, so I add the components. So I get negative 6 times 10 to the negative 6th, because that's plus 0. 0 plus 6, so it's 6 times 10 to the negative 6. And then 0 plus 0, Tesla. That's it. Okay, now what happens if the direction of current I2 changes? So what happens up here if this is into the board? Well, now, oh, I got that backwards. Negative. Okay, that's actually the second case. The first case, this would be, wait, I had it. No, I'm sorry, that's right. Okay. I was looking at what I just drew. So if the magnetic field's coming out like this, then the magnetic field due to 2 would be down. And the only thing that would change would be the sign of this right here. So this is 1, 2, B would now be equal to negative 6 times 10 to the negative 6th, negative 6 times 10 to the negative 6th, 0 Tesla. Now, that's the answer. but I asked for the vector value. So if you want to find the magnitude, you could do that, but I wanted this vector. That's it. Okay. The end. One more problem.